Today, we'll be walking through how to create a live tool radial drilling and tapping program using Haas's Visual Programming System. When programming with VPS, as we usually call it, you don't need to know G-code to create programs. The VPS templates guide you step by step in an easy to understand way and get you going quickly. I've got my blank loaded in the machine, and after we've turned the OD and added these flats, I want to drill, spot drill, and tap these 4 holes 90 degrees apart. So let's get started. First, I'll press the Edit key to get to the program generation page. Next, I'll cursor over to highlight the VPS tab and arrow down to the VPS folder. Then, cursor right to open the list of templates. The radial drilling template is in the live tooling folder or directly on the list, depending on what software version you've got. All right, the first entry is for the tool number. This defaults to the tool number already in the cutting position on the lathe. And since this is the drill I'll be using, I'll leave this set to 10. You can change this, of course, if the drill is at a different station. The next variable is the tool offset number. This defaults to the number that matches the tool number we just entered. Having an offset number that matches the tool number is good practice when programming, but in some cases you might want to change it. You have the option to choose any number from 1 to 99. For now, I'll leave them matching. Also, the template will check to see if there is a value in the offset number chosen. If there isn't, it will display the message tool offset is 0 and hide all other variable rows until the tool offset is set or another offset number is chosen. This ensures we don't have any issues later on. Next, we define the work offset. This is typically set to G54, but if you need to change it, you can choose from G54 to G59. Next, we select flood coolant on or off. This is set to on as default since it's the most common way of machining. Change it to 9 if you want it off. Then, if your machine is equipped with high pressure coolant, you'll see this row where you can select on or off. We'll leave this set to off as well. Next, we define where we intend to start drilling. We set this as a diameter number, just like a turning tool. The template automatically looks at your tool length and machine travel to calculate what the maximum and minimum ranges are for this variable. The diameter of this slug is 2.75 inches, but we'll be turning this down to 2.65 before the drilling operation. So I'll set this number to 2.65. If the template is limiting the allowed diameter range too much, try shortening the tool length or using an offset live tool head to gain more room. Next is the rapid approach distance in Z-axis. This determines the distance from the part face to where the tool will switch from rapid motion to feed motion. This value defaults to 0.2 inches, and I'll leave it set to 0.2. And of course, don't forget to use the rapid override buttons to slow things down when you run the part for the first time. Next, we set the approach distance for the X-axis. Again, I'll leave this set to the default 0.2 value. When rapid approaching the part, it is usually safer to do so along the Z-axis first and then the X-axis to make sure you have enough clearance moving forward towards the chuck. Next, we set the RPM speed for the drill. For this .265 drill, we'll go with 6,000 RPM. If you need help finding recommended values, you can use the speeds and feeds calculator found under current commands. Next, we define whether we have a single or multiple drilled holes. I'll change it to M and press Enter. Selecting multiple holes will add a question for the amount of holes to be drilled. Next, the C-axis start angle line allows the programmer to drill the hole at a particular angle if the drawing requires it. We'll leave this set at 0 degrees, which will start the first hole at C-axis home position. We'll enter 4 in the next line since we're drilling 4 holes at 90-degree intervals. Keep in mind that whatever multiple hole quantity you choose, the holes will be drilled with equal angular spacing unless the G-code program is manually edited after it's generated. The Z-axis distance entry sets the distance from part 0 to the center of the drilled hole along the Z-axis. This value on my drawing is 0.3 inches, so I set it to 0.3. Next is the R-plane value. This is the distance the drill retracts after the drilling operation to clear chips and gain clearance to move to the next hole. I'll set this to 0.03 inches as well. The drill depth line, of course, sets the depth you'll be drilling to. It's the dimension from the edge of the part to the bottom of the hole. The drill depth on the print calls for a 0.6 depth, so I'll enter 0.6. The feed rate value will of course depend on your workpiece material, the drill type, and desired chip load. Once again, if you need help finding recommended values, you can use the speeds and feeds calculator on the current command screen. I'll be using a feed rate of 32 inches per minute. Now at this point, we're done with the machining section, and now we'll just program retraction moves and finalize the program. Retract X home does just that. It retracts the X-axis upward away from the spindle all the way to home position before the Z-axis moves. In this case, I'll enter Y for yes. If you want to specify where the X-axis moves, then answer no, which will expand another row and you can define a specific position. Retract Z home works the same way, except now we're controlling the Z-axis. I'll leave this set to Y as well, so the Z-axis retracts all the way home. Here also, entering N will open another line where you can enter the particular Z-axis position you want if you want it to retract a shorter distance before the next tool change. The final line selects the M code we'll end the program with. Since I'm going to use this drilling program in the middle of my larger part program, and I'll be adding a tapping cycle right after it, I'll select M01 to give me an optional stop if I need it. Now let's generate the actual drilling operation and place it in our existing program. I press F4 to generate the code and then 1 to insert the clipboard. Now I can drop it in my program right after the OD turning operation. Okay, so we've got our drilling program added to our part program. Now I want to spot drill each of these 4 holes so the tap will start properly. Making a spot drilling routine in VPS is pretty much exactly the same as the drilling routine we just did, except that you'll be setting a much shallower drill depth for the countersink. So we're not going to bore you with stepping through all of that. Let's move on to the tapping operation. Since we'll be tapping the same holes we just programmed to be drilled, a lot of our values will be the same or quite similar. Using the left arrow, I'll back out to the list of VPS templates and select radial tapping. To start, we're greeted with the same questions as before: tool number, tool and work offset numbers, and coolant on and off. Moving on to the tap start point, I'll enter the same position where I was drilling, and my Z and X rapid approach values I'll leave the same. The tap RPM I've already calculated using the feeds and speeds calculator. I'll be using 700. I'm using a 5/16 18 tap, so I'll leave this set to inch. And my threads per inch equals 18, of course. I'll be tapping multiple holes, of course, so I'll enter M here. We started our drilling at a C-axis angle of 0, so we'll do the same here. And we're tapping the same 4 holes, so I'll set number of holes to 4. I'll leave the Z-axis distance the same as well, of course, since I want to tap in the same place along the Z-axis where I just drilled. The R-plane I'll leave the same, and my tap depth I'll set to 0.5 inches to match the drawing. To finish up, I'll enter Y and Y for the retract values and enter 1 again to put an M01 at the end of this program. Now I'll press F4 to generate the G-code and copy it to my clipboard and then into my main program right after the spot drilling routine. And there you have it. If you've got radial drilling and tapping to get done, check out these VPS templates, answer some easy questions about your part geometry, and the control will generate the code you need so you can get on with making parts. Thanks for watching, and we'll see you next time.